name is Dan Oved. I'm going to talk about how we centralize the state of a real-time multiplayer gaming application on the server using Redux. The project was for Equinox Fitness, which is a major fitness company in case anyone doesn't know them, with fitness centers across America and Canada and the UK. And the Pursuit is essentially a gamified spinning class that streams real-time bike data from the class onto a huge projected screen behind the instructor that shows how everyone's doing, visualizes how their performance is, and essentially drives everyone to compete through games and cycle harder. So here's a little video of what a typical Pursuit class looks like. So a little about Pursuit. It's currently in 25 locations across America. It's soon going to grow to 40. There's about 20,000 riders per month, that's attendees, about 700 classes per month, and in each class there are about 500,000 points of data. The data challenges aren't really about lots of data, it's about displaying, not lots of data at big scale, but displaying a lot of data in real time as soon as it happens. A typical class, so essentially when a class starts, an instructor will configure what the games are for the class through an iPad app. They will essentially choose 3 to 5 games. The games will either be team or individual based games, and essentially there's 2 types of classes. There's build and burn. Build games are more, I'll show you that actually in a second. But essentially every game has metrics that are very different from game to game, so the calculations are different. And essentially, so if you look at the build games are essentially endurance-based games. So they are focused on running a long distance at a sustainable pace over multiple rounds. Essentially the idea is on a first round, you're gonna set a pace. Second round, you're gonna try to match that pace. So this is a game 3 peaks where it's not a team-based game. It's essentially broken out into everyone has their own bike represented on the screen. The first round, you try to set a distance that you know you're going to be able to hit the second and third round. The second round, your circle drops down to where it started, and you have to try to meet that pace for the second round. And then, if you beat that distance, you want to try to match it on the third round. And then we essentially rank all the bikes by their current distance, and then your circle will light up based on if you're on pace or not. So that's a typical burn game. They're more endurance-based. That was build, I'm sorry. And then burn games are more sprinting, high-intensity workouts over a short period of time. So this is a very simple burn game called Heat Wave. Essentially what this is both teams try to generate highest average watts. And it's like a tug of war where over, let's say, 30 seconds, or this is a 45-second round, they will try to push the line in the middle towards the other side. And essentially where the line is at the end of the round is the winner. So whoever pushed it the furthest. So now a little bit about how the system is set up. Essentially, this is in each studio, there's a bunch of bikes that are sending bike data over ANT+, which is a common protocol used in fitness devices. It gets picked up by a bunch of WASP processors which sit on the roof of the studio, convert that to a Wi-Fi signal on a private network. That gets sent essentially to a server that's located in the studio. That server essentially has a bunch of services. One of them is the WASP processor, and the WASP processor will take that data, take all the bike data, batch it, and then send it really quickly to broadcast via WebSocket. Then what we're going to mainly talk about is the Node app, which is built in Pursuit, which is built in Node, the Pursuit app, which is built in Node. And that essentially gathers all this data in real time, aggregates it, and then displays it on both the presentation screen and the instructor console. So one thing to know about this exists in every single club for the main reason that it needs to work without internet. Essentially, we can't have a class stopping if the internet stops. Also, we want just the data to reach the bikes to all the different consumers of the data instantaneously, so it's a lot easier. Also, the server needs to have a very good graphics card because a lot of the visualizations are rendered in WebGL. So when we initially took over the application, essentially it was a Node app, the presentation screen, and the instructor console. Instructor iPad app. Instructor iPad app is essentially a web view. The presentation screen is also a web view that renders WebGL. But the main problem we faced was that state was pretty much scattered everywhere. So for example, in the Node app, it would do certain bike calculations, and then it would do certain team-based calculations. It would send that to the presentation screen. The presentation screen would then do game-specific calculations. It would store that as state on the presentation screen, and then it would send that back into the Node app and back out into the instructor console. So a lot of the game calculations were done in the presentation screen, and they would reach the iPad app at a delayed rate. So essentially, there are multiple problems there. The data would take a while to travel from the presentation screen back to the Node app server and into the instructor iPad. And so it would often be out of sync. The data was located in multiple places. So let's say the instructor iPad had to do some calculations, and we all of a sudden discovered a bug in it. It was nearly impossible to trace where the bug came from because who knows where the source of that calculation was from, and who know on what platform, on what system that existed on. Another problem, for example, time was done in all three places. So there's like a countdown timer on top of the presentation screen, a countdown timer on top of the iPad app, and then the Node app also had time, and this would often get out of sync. So if the instructor was seeing 3, 2, 1, go on the iPad, and they were saying go, and then like that was out of sync with what's on the presentation screen, then that would kind of be a pretty big problem. So we decided that, and another problem, sorry, essentially if there's a JavaScript error in the presentation screen or you had to close it, the whole application would crash because half the state was lost. And then you also couldn't have multiple presentation screens open. You could never refresh anything. So we decided we just really needed to centralize the state in one place, and in a really easy to understand way. And we looked at this really as this whole system as just essentially a series of events that boils down to current state, which is essentially kind of a functional programming approach, where essentially you have events over time, and that the current state of the application is a result of all the events over the history of time. So we looked at a few different solutions for this. Essentially, we originally looked at reactive extensions. I don't know if anyone's used that, which we thought would be a good solution, but it's really complicated and it's tough for a lot of people to understand, and we want a bunch of developers to be able to work on this. We decided we wanted to use React on the browser to render all the HTML and WebGL components because essentially this React could get the state as it currently was and show or hide elements automatically based on what the state was, or basically fast forward to the current screen. And we also wanted data to be instantaneously shown on the browser in the clients. And one of the problems was before is because it was actually, a lot of it was written in jQuery. It was very poor performance, and essentially they would buffer the bike data to every 1 or 2 seconds to deal with like poor performance updates and slowing down the computer. So essentially, if people were biking, it would take their data a second or two to display on the screen, which isn't an ideal situation. So we ended up with this, doing a lot of prototyping, and we ended up going with Redux. Redux isn't normally used on the server. It's most normally used in the browser. And just a quick overview of what Redux is. Essentially, it stores the entire state as a single JavaScript object in a store. A Redux store consists of actions, which sends information to the store about exactly what happened that's corresponding to an event. And then it contains reducers, which deal with different parts of the state in a small manner and change themselves in response to these actions. And altogether, that forms a store. We use Redux because it's well documented. It's pretty simple to understand. And it's just provides a standard way that we could represent the state. And also one of the huge benefits of Redux is it's very testable. You can test actions really easily. You can test reducers really easily, and you can test selectors, which I'll talk about in a second. So essentially, reducers store the data, actions describe the events, and then selectors essentially take the minimal amount of data stored in the reducers, and then we'll do calculations based on that. And we use this pretty heavily around the application, where we just store the minimal amount of data in these reducers, and then use selectors to calculate it, do calculations. And reselect is the common library everyone uses for this, which essentially it memoizes the calculation, so it provides kind of layer of caching. So it'll see, did the source data change? No. Then I don't need to recalculate myself. So you can keep calling this selector that could be theoretically very performance intensive over and over, and you won't suffer any penalty because it will know not to recalculate it. So a very simple example of what this could look like. Let's say you have a shopping cart, and you want to know what the total with tax is. So you could have two simple reducers, essentially. One is the items that are currently in the cart, and the other is the tax rate. Now, how do those things get their value? When an action is dispatched, that item added to cart, this reducer will listen for that action and add the item to its list of items. And then another thing, if a user signs in, the JavaScript, the client can, through an AJAX request, fetch the user's information, get their tax rate, and then that would be stored in the reducer. And then essentially you use selectors to dynamically calculate essentially the total before tax from just the items. You combine that with the tax rate to get the tax amount, and then you could get the total with tax by combining those two selectors. So just a very simple, quick Redux. What's considered Redux best practices is store the minimal data you need in dumb reducers, have very little logic in them. They just are there to store the data. All the complicated logic should go in actions and action creators. And anything that can be calculated from the reduced state should be done in selectors. So what we ended up with at Pursuit is essentially kind of a unidirectional data flow, and I'll kind of explain how that works. So the bikes up at the top of the screen, they essentially send a lot of bike data at a rapid pace. We buffer that, and then after each buffered set of actions, after each buffered set of data, we will dispatch an action called bike data received. The other two sources of data that come in are essentially actions that are caused by the instructor on the iPad, essentially pressing buttons like selecting the class, configuring the class, starting the class, or ending the class. And then there's another thing that's going on. There's essentially a clock that's just constantly ticking and dispatching an action called advance time. So those three actions, those sets of actions get dispatched to the store. The store's reducers will update themselves, and then every time that happens, essentially the state gets changed. And then we will use selectors in front of that to determine what the clients actually need. So every time the state changes, we use these selectors to select what's needed for the client, and then we basically get the deltas from what was there before to not send the entire state every single time, and then we broadcast that to the clients via WebSocket. On the clients, there's a very simple Redux store, which we just use so we can use the standard tooling around it called, it's just the only action it gets is that the state changed, and it will essentially contain the entire state that was sent and just the delta. Basically, every time there's a delta, it'll just update that part of the state. And then there's essentially a React DOM elements get rendered and React WebGL elements get rendered. And we're able to render React WebGL elements because you don't necessarily have to render DOM. You can just create a component that represents a WebGL element. I mean, that's for like a whole other talk, but because we're able to, it's really beneficial to be able to just send the state to this React components, and they will show or hide themselves based on what the current state is and animate and do all those things. So an example of how we use Redux and our selectors. Essentially, let's say we want to get what the current screen is that should be shown. So the three actions that could happen here are the class is started, and then there's a class start time reducer, which that's all it's going to store is a class start time. The time advance I just showed you on the previous screen, on 2 screens ago, where the clock is ticking, and then that'll just get stored in a reducer that has the current time. And then when the instructor configures a class, that'll get stored in the class configuration reducer. And combining current time and class start time, we can get the time that was elapsed in the thing, and then combining that with the configuration, we can get what the current screen is. And essentially, that gets sent with the state that goes to the client, and then connected to a React router to basically determine which component is currently rendered. And all that's done in the browser, but all the selectors are done on the server. So here's an example of how we do game calculations. Essentially, we know the current game based on the same logic that we did before by determining what the current screen is. Then we can combine that with the bikes. There's like the same, we basically geographically split up the bikes into teams, and based on what the current game is, we know what the logic is, and then we can actually store the teams are calculated in the selector because that source data never changes. And then essentially the bike data received action I was talking about before, that goes into 3 different reducers. That can go into 3 different reducers. Essentially, the game starting bike data, what the current bike data is, and then we can essentially combine that too into getting the distance by bike for the current game. And then we can combine that with the teams to get the distance by team. And then we can basically use the distance by team to select the winners, if that's like just a simple distance-based game. And then essentially each screen we configure which selectors get sent to the client. So this isn't really a talk about reactive extensions, but I mentioned about it. So we use reactive extensions very minimally just to essentially buffer the bike data, and it makes certain things really, really easy. Reactive extensions essentially just underscore for events or streams. I'm not going to go that much into it because it's like a huge topic, but we're able to, like, with very, very few lines of code, essentially get thousands of bike packets per second and buffer it in batches of 100 milliseconds. And this is how we kind of link reactive extensions with dispatching actions. So essentially, every 100 milliseconds, we're going to get bike data that's batched, and then dispatching action bike data received. So looking at just kind of the way the whole thing flows through, and this is actually pretty common for game architecture, for multiplayer gaming architecture, but they don't I don't believe that Redux is used anywhere. So essentially, everything starts with actions at one side. Those go into the current state. You do calculations, and then you just select the deltas from the calculations from now versus the previous time. We send that via WebSocket to the client. There's a simple Redux store that connects to React router, which will determine what the current screen is, and then that'll render the components inside of that. And then the React components will render a DOM or WebGL. And then also in the instructor console, the React components will, on occasion, they won't actually dispatch actions on the store on the client. They will send them via WebSocket back to the server, and they will go back to the actions on the server, and then everything's kind of in sync because the same state gets sent everywhere. And one of the things this lets us do is we created a sandbox, which is essentially the entire client-side application with all the data faked from the server, which makes it incredibly easy to develop new games. And essentially, I will show you that right now. Essentially what that is, well, before I go into that, is it's essentially everything on the right half of the screen, the client, with an additional ability to do state faking actions. This is just like a thing that exists only in the sandbox. And essentially, that will just modify the state to be what it'd be if it came from the server. So it's really easy to modify the state if all the state is one JavaScript object. And it's really easy to see where everything is. So I'll show you a quick demo of what our sandbox looks like. So this will kind of show what the games look like. First, I'm gonna. Displays. So at the most basic level, we let people view the basic circles that represent you in a different game. So build is essentially this thing. You're essentially, the more power you have, the thicker your line will be, the more RPM will have, the harder it will spin. These are different things that can happen to the circle, solidify. And this is, by the way, a React component with WebGL inside. And then, so if this is an actual game, we're able to basically fake, this thing that's driving this is exact copy of the state that would be coming from the server, except it's faked entirely on the client. We are able to, I could just say like they're moving much faster or slower. I'm going to show their ranks, which are going to change really fast. I can end the round early, which will basically make them go down and create their circles again. So yeah, here essentially it's just all this controls up here is doing is dispatch is essentially faking the state as it would come from the server. And then let's see another one. This is like a much more simple one. This is a animation that at the start of the class the disks will get the whole animation will get more intense the more power everyone as a class has together. So here I'm just going to modify the class average power. I'm going to slow it down. I'm going to increase it, and you'll see it grows. And this is really good tool for someone new to their project to use because they can kind of see just from how the client side works, how the data connects to the client, and how it follows all the way through. Just another one that I'll show you. It's the one that I was showing you before as a picture. So I can here like change the average watts. It'll push this thing to one side. Yeah, so these are kind of like what the games look like. And yeah, as you notice, this is using React Router. It's like single page thing. That's not working. One of the challenges of a sandbox like this is you have to also maintain this thing because it can get very out of date with very easily out of date with state from the server. That's pretty much it. I'll just put up my contact information and then I'll let people ask questions. Yeah, so this is my professional personal email. GitHub, Twitter. I rarely use Twitter, but yeah. Any questions?
How about a quick round of applause?
So I don't know that much about developing video games, but
Yeah.
I think like a lot of other people, I've like read some random tutorials and like screwed around with Unity for like 5 minutes. And what I saw of those was this idea of this sort of entity component system kind of thing. And seeing this, like this seems like a fairly different approach. And so I was wondering if you could speak to how the approach of using Redux to like store and manage state like compares to what you would do with an entity component system, compare and contrast. Like are they complementary, do you know?
So I don't have that much experience with Unity, but I know they have their own system. I'm pretty sure they have their own system for streaming the state the same way. I mean, Unity is really easy. It's just drag and drop.
Right.
But I don't know if, so I'm not really sure with how that compares to that. But I know that like we work with some game developers who have rolled their own system in C++ or something that does something similar where it essentially has all the state on the server and just streams the deltas to the clients. But Redux seems like a really good way to do that. Yeah.
So 2 questions. Yeah, so selectors, would you describe those more as like similar to getters or similar to, I guess, post-reducer middleware, like, Redux middleware? And also, how does React work with WebGL when like there's no tree, right? Like a DOM tree.
So, okay, so to answer what was the first question? They're essentially getters. It's essentially like writing a query against a database, except if the source data didn't change, it's not going to recalculate it. Answering your second question, Essentially, to do this with, so with React, if you return null, you're allowed to return null from components. And essentially, when, so we use Three.js, which is like a way to write WebGL code. And we also use, there's some people that, we have some shader code, but essentially, Three.js is a way to write WebGL using JavaScript. The problem with a lot of the Three.js code is it's written like stream of conscious. It's just like a huge statement with tons of loops and everything. So you can actually wrap each of those in, you can wrap different Three.js elements in React components and just have React component return null, render null. And then essentially the properties that get passed to the React component you can just use to update things on the Three.js object. Someone's actually created a library called React 3, which does this, but it's in the early stages, but it's definitely worth checking out.
Thanks for your presentation.
Yeah.
I'm new to Redux as well. Not new to React, but the concept of selectors is something that I've never heard of until just now.
Uh-huh.
My question is similar to this guy's, but like where do they live? Do they live kind of on the component level, or do they live in the producer area? Like how do you organize that within the application?
Yeah, so essentially if you're using some, yeah, so he was asking basically where do selectors exist in Redux, and how do they essentially, are they part of middleware, do they exist outside of it, or, and where do they exist, and how do the components grab from them? If you use something like, wherever you're grabbing the state from the store, you would essentially pass the entire state object to your selector, and then your selector would grab what it needs from it. So if you're using React to Redux, for example, where there's the method map state to props, which takes the entire state and then you choose what you need from it, you would just have the selector take the entire state and then just map that to a property.
So it's kind of,
Yeah, essentially if you're using React to Redux, it's in map state to props. That's where it would go. Yeah. Yeah, no problem.
I have a couple questions. The first one is, how much memory does your Node server use when you're running this?
Mm-hmm.
And then the other is, if you have like multiple processes, like if you're running your Node app with like PM2 or in a cluster mode, have you experimented sharing that Redux state, storing it in Redis, so each of those processes could use that shared state?
So the memory footprint isn't that long because the Redux store isn't storing that much data. It's just storing what it needs. But I've thought about this before because let's say, like I feel like this could exist in a distributed environment where one of the steps before you dispatch the action is you grab the state from a Redis thing, and then you just create a store around that, and you dispatch the action on it, and then you can send that off. But we haven't really needed to run in a clustered environment because it's really just one class running at a time at every studio.
How do you run your Node app in production? What do you use to start it up?
So unfortunately, it is they're Windows machines. So we essentially use Forever to start it. It's an existing thing we inherited. So yeah. Ideally, I mean, when we have time, we'll migrate it to Docker.
so when the data travels from the server using selectors, are you selecting basically like a snapshot of the state and you send the snapshot as is of now to the client?
Mm-hmm.
Not the deltas.
So we do the snapshot, and then we basically we compare that with the previous snapshot and see, did this snapshot change? So essentially you have a selector for all the different things. So let's say you have a distance by bike selector, and you have a distance by team selector. We will select everything every single time because the performance theoretically wouldn't be a problem. But before we send it to the client, we'll see, did distance by bike change? Don't send that. Did distance by team change? It did, so send it. So essentially we send all the keys that change, and then on the client, it'll just update the parts of the state that it got.
So how big is your state tree? Like, and what are you collecting from the bikes?
So essentially from the bikes, what we get is, it's really not that big. I mean, it's pretty small because we just store what we need. It's a bunch of JavaScript objects. Some of them are arrays. Some of them, so for example, let's say we want to store the rounds. We'll denormalize that. That'll be an array of rounds, but that's just like has a start time, starting bike data, ending bike data. What we store from the bikes is essentially the distance, the power, RPM. That's what we get from well, essentially we get like distance, kilojoules, current power, which is watts, and then RPM. And then we can basically take that from one bike at one time to, let's say, 10 minutes later and calculate whatever we need from that base using selectors. Yes?
So you mentioned that you chose Redux over like observables because it was easier to understand, you can onboard team members, and then in one of your slides I think you showed observables, so can you talk a little bit about mix and matching?
Yeah, so I mean, you can use observables to do what Redux does, but it's really not well documented, and it's really hard to debug. So we just use it for around the edges, essentially like something that's kind of tricky to use. I would always just say just use it in a small place, and we thought it would be a really good place to use it for buffering a lot of data that comes in via stream.
So it's like debouncing your web sockets?
Debouncing, exactly. That's all we use it for, essentially. Yes. We wrote that. It's just essentially comparing. We do deep equality comparisons for every key of the straight days that's selected. But it would be nice if that was provided.
Is that a thing you have to do when you do it on the server?
Yeah, we do it on the server. So the presentation screen is connected to directly to the computer, so there's no Wi-Fi packet, but the instructor iPad is over Wi-Fi, so we had to kind of do that for that. But yeah, we do that on the server. Essentially, it's like the state changes, subscribe to that event. When the state changes, select what you need from it, and then do the diff based on the previous one. And it's just important that we have to null values out to get, I forgot why, but we just null values if they're no longer valid. Yeah. Yes.
So I'm curious if you guys use Nodejs or have any experience with it. And I was also curious if you ran into you ever ran into a situation where you had to serialize data to sync a state across the network with data that wasn't easily serializable to JSON, so like a symbol or functions or anything that was sort of not just raw data.
So to the first question, we use immutable in a few places, but we tried using it everywhere, and it's really confusing. It's really not well documented, and stuff that we could super really easily do with Lodash, we'd have to jump through hoops to do with immutable. But I wish, I mean, if we had more time, it also like, you know, you need people to understand it, and there's a learning curve, and like teaching people coming onto the project about Redux, Redux and React the way we're using it, and then to have them try to learn immutable, with which the documentation doesn't have any really good examples of how to do anything you want to do, would be really tricky. But I would totally use it if it was better. Like I think it's totally right for doing, for example, the diff, comparing the diffs between the previous and current state. Yeah. Yes.
So I wrote like a little game with Redux myself once. So when the state or the store only lived on the server, and I had my clients dispatching actions. I was wondering if you had to deal with like the latency or the lag, because by the time your actions reach the store, the state will have like changed.
Well, because everything's kind of on a local network, it's like pretty instantaneous. But the state also has, the action creators have to have some kind of logic to check if it's going to do something to out-of-date state. So like if it does something that, if like you send an action that's out of date, then the action creator would have to do some validation that you could still do it. But we didn't really have that much out-of-sync problem because we have the server in the studio, which is also, I mean, having the server in the studio is also a huge pain because we have to deploy to like 25 locations every time we have new code. So, yeah. Yes.
Are you using any ES6 or is it like primarily?
Oh yeah, it's all, we're all using like ES6, Babel, Webpack, with very strict. One of the things we added really strict linting rules because people wrote code in so many different ways. So yeah, we definitely are into ES6. Like I think the example I showed you was very ES6y. It was like this thing. It's like yeah.